Hi everyone. Today I'm going to do a second lesson on radicals, and this lesson is on adding and subtracting radicals. So there are four warm-up questions, and I want you guys to try these questions by yourself, and the answer key is already posted on D2L. So I'm going to start our lesson. Okay. Adding and subtracting radicals is very similar to adding and subtracting polynomials that you learned in grade 10. And you know that we can only add or subtract polynomials if the terms are like. For radicals, in order to be like term, both the radicand and the variable, part of the coefficient must be the same. Also, the index must be the same. We can always verify answers by using a calculator. Okay, let's do a few example questions and then you will know what I mean by like terms and radicals. Okay, so first question is 8 square root 3 plus 4 square root 3 minus 5 square root 3. Whenever you're adding or subtracting radicals, you always have to check for two things. First, index. Okay, so if you see here, index for this radical is 2. And in the second term, the index is also 2. In the third term, the index is also 2. Second thing, you will check for radicand. Radicand here is 3. In the second term, also, the radicand is 3. And in the third term, also, the radicand is 3. It means that we can solve these terms. Okay? So I'm going to take square root 3 common. So I'm left with 8 from the first term. I'm left with 4 from the second term. And from third term, I'll get minus 5. I'll simplify this. 8 plus 4, negative 5 is 7 square root 3. Okay, so this is our answer. And second question, again, you're looking for two things. First thing is index. The second thing is your radicand. Okay, so index in all these four terms is 2. So we're okay with it. Now we have to look for the radicand. But the radicand is not the same, right? So we'll try to simplify these radicands first. So square root of 48 can be written as 16 times 3, and square root of 180 can be written as 36 times 5. I'm trying to break this radicand in terms of product of a perfect square and some other number. Okay, so 16 is a perfect square, and here in this case, 36 is a perfect square. Okay, square root of 12 can be written as 4 and 3. 4 is a perfect square here, and 45 can be written as 9 and 5, and 9 is a perfect square here. Okay, so square root of 16 times the square root of 3, we can write them separately. Okay, same thing here. We can write square root of 36 and square root of 5 separately. And same thing here, square root of 4. And this is square root of 3 plus 6 times square root of 9 times square root of 5. Okay, square root of 16 is 4, square root 3. And square root of 36 is 6, square root 5. Minus square root of 4 is 2, square root 3. Plus, and square root of 9 is 3, and 6 times 3 becomes 18, square root of 5. Okay, so let's simplify all these terms here. So let's open this bracket first. When you open this bracket, because there is a negative sign in front of the bracket, so these signs inside the bracket will switch. So it becomes negative 2 square root 3, negative 18 square root 5. So here if you see square root 3 and square root 3, these two are like radicals. So we'll solve them together. And here square root of 5 and square root of 5 are like radicals, so we will solve these two together. So this is equal to 4 square root 3 minus 2 square root 3 becomes 2 square root 3. Now here 6 square root 5, take away 18 square root 5 becomes negative 12 square root 5. Okay, so this is your answer. So remember, whenever you're adding or subtracting radicals, you're always looking at the index and you're looking at the radicand. So here we cannot solve these two terms together. The reason is the radicand is not the same. Okay, here radicand is 3 and here radicand is 5. Okay, let's do another example. So here in question 3, you can see index is 3 in each term, but our radicand is not the same for all three terms, right? So we're going to simplify the radicands so that we'll try to get the radicand same, and then we'll simplify those terms with the same radicands. Okay. Okay, 8. And because the index is 3, I'm gonna break 16 as perfect cube and some other number. 8 is a perfect cube and 8 times 2 is 16. Okay. And cube root of 54, 54 can be written as 27 times 2 because 27 is a perfect cube, plus cube root of 250. 250 can be written as 125 and 2. 125 is a perfect cube. Okay, and this is equal to 8. We can write them separately. Okay, now let's simplify this. Cube root of 8 we know is 2, and 8 times 2 is 16. So this becomes 16 cube root of 2. And cube root of 27 is 3. 4 times 3 becomes 12. And the cube root of 125 is 5. And this becomes 5 cube root of 2. So you can see here, all the three terms have same radicand, so we can simplify these three terms. So 16 take away 12 plus 5 is 9. So this is equal to 9 cube root of 2. So this is your answer. Okay. Now let's do uh, a few questions with variables now. So in the radicand, you have variable with the constant. Okay. So let's simplify our first question. So whenever you have a variable in the radicand, so you have to always list the restrictions too. Okay, so let's do the first question. It's square root of 20 x cubed minus 3 square root of 45 x cubed. So let's break 20 first in terms of a perfect square. So 20 can be written as 4 times 5, and x cubed can be written as x squared times x. Okay, and same way 45 can be written as 9 times 5, and x cubed can be written as x squared times x. Okay, I'm gonna write all these radicands that are in first term separately. So I can write them as square root of 4, square root of 5, and square root of x squared times square root of x. Okay, and in here I can also, in second term also, I can write all the um, the radicands separately. Okay. Okay. Now let's simplify them. Square root of 4 is 2. I don't know the square root of 5. And square root of x square and square root cancels out. We are left with just x. Okay. And then what is left? Square root of 5 and square root of x. Okay. Minus square root of 9 we know is 3, and 3 is already out here. It becomes 9. And we also know that square root of x square is x, because square root and square cancels out. We are left with x. And we'll write square root of 5 and square root of x as it is. So let's simplify this. So I can write these two square roots together in one square root. In the same way, I can write these two square roots as one square root. So now you can see that these two radicands are same. So it's 5x here and 5x here. So we can simplify these two radicals. So 2x minus 9x is negative 7x square root of 5x. Okay. So we are done with this question, but whenever you have a variable as a radicand, you always have to write your restriction. So if you see your restriction here, because the index is even, that is 2 here, so you cannot have a negative radicand. Okay, so you cannot plug your x value as negative. So your restriction is your x should always be greater than equal to 0. Okay. So I'm going to do one more question with you. I'm going to do question number 4, and I want you guys to try question number 2 and also question number 3 by yourself, and the answer key, as I already mentioned, is posted on D2L. Okay, so I'll do question number 4 with you. Okay, in question number 4, we have 1, 2, 3, 4 terms. And then we also have same index for all these 4 terms. Index is 3, but our radicands are different. Okay, so we try to simplify these radicands first. Okay, so 16 can be written as 8 and 2. Because index is 2, so I'll break 16 in terms of a perfect cube number. Okay. And v to the power 5 can be written as v cube into v square. Okay, again, if you remember exponent laws, whenever you are multiplying two terms with like bases, the powers are added. So v cube into v square is actually equal to v to the power 5. Okay. So next, I cannot break 3 because it's a prime number. So I'll write 3 as it is. And w to the power 4 can be written as w to the power 3 into w plus 2w. And 24 can be written as 8 times 3 into w plus 5v. 54 can be written as 27 times 2. Again, 27 is a perfect cube, and v squared with it. Okay. Okay, let's simplify it. We know that cube root of 8 is 2, and this cube and cube root cancels out. So 2 and v goes outside, and inside this cube root, we have v square, or we also have 2v square. Okay. Okay. In this, we have cube root and cube cancels out. So we have w that goes outside the cube root, and inside we are left with 3w. And in this term, we have cube root of 8 is 2, and 2 times 2 is 4w, and inside the cube root we have 3w left. And next we have 27, and cube root of 27 is 3. So 5 times 3 becomes 15. And then there is also v outside. And then this becomes 2v squared. Okay, so let's simplify these radicals now. So if you see this first term and the last term, both these terms have the same radicand. So we can simplify this and this together. And if you look at the second term and the third term, they both have the same radicands. So we're going to simplify these two together. Okay, so now 2v plus 15v becomes 17v cube root of 2v squared plus 4w plus 1w becomes 5w cube root of 3w. Okay, so again we have a variable in the index, in the radicand, right? So we have to write the restriction here. So here, because in the first term, because it is square here, right? So even though you put negative number, because of the square, it will always be a positive. And whenever we have index odd, we don't worry about this. And you can even check on your calculator. If you simplify this, your answer will be -3. Means you will not get an error on your calculator, right? So this will be still -3. But if you try to simplify this on your calculator with -9, you will get an error on your calculator, okay? Because whenever your index is even, you cannot have your radicand negative. But if your index is odd, you can have your radicand negative, okay? So in this case, we have v could be anything. You can say v belongs to all real numbers. And then here, as I already mentioned, that whenever your index is odd, you can have any value of radicand. Your radicand could be positive, it can be negative. So your w can also be anything, that is w belongs to all real numbers, okay? So let's do our last question. It's a word problem. It says a square with area 24 centimeter square is placed beside a square with area 50 centimeter square. In simplest form, write a radical expression for the perimeter of this shape shown below. Okay, so if the area of this biggest square is 50, what would be the side length? We know area is always equal to side square, right? If area is 50, so what will be side? It will be square root of 50, right? So each side is square root of 50. Okay, and let's look at the smaller square. Smaller square has area of 24. Okay, so each side length of smaller square is of 20 for square root 24 centimeter. Okay, now we have to write a radical expression for the perimeter, and we know perimeter is sum of all sides, right? So we're gonna write the expression for perimeter. Perimeter is equal to sum of all the sides, okay? So perimeter, this is equal to, if we add all these sides, square root of 24, square root of 24, and square root of 24, right? This is 3 times square root of 24 plus, let's add these three sides of bigger square. Square root of 50, square root of 50, square root of 50. So it's 3 times square root of 50. So let's have a look on this smaller side, this small side. Let's calculate the length of this small side. So the length of this, we know that this full length is square root of 50. And we also know that this small length is square root of 24. So the remaining chunk, this, is equal to square root of 50 take away square root of 24. Okay. So let's simplify this. So this is 3 square root of 24 and negative 1 square root of 24. It becomes 2 square root of 24. And this is 3 square root of 50 plus 1 square root of 50 becomes 4 square root of 50. Okay, two more steps, then we are done. Square root of 24 can be written as 4 times 6, and square root of 50 can be written as 25 times 2. Again, we'll break these radicands in terms of product of a perfect square and some other number. 4 is a perfect square here, 25 is a perfect square. Okay. Square root of 4 is 2. Square root of 6 is as it is because we cannot find the square root of 6 as a whole number. Square root of 25 is 5. And square root of 2 is as it is. This becomes 4 square root of 6 plus 20 square root of 2. So this is our answer. Okay, what I want you guys to do for homework is to do these practice questions that are on pages 6 and 7. Okay. Okay, that's it for this lesson.